So this is our notes starting on trig identities. This is chapter 5, section 1 of your book, as highlighted in the upper left. So these are about trig identities and our ability to use them to substitute into known things to rearrange them to make them simpler. So the ones we need to worry about are going to be they're called the reciprocal identities. Those are these three right here. I'm kind of bubbling in. Those are called the reciprocal identities. Then you have the others that are right here. These are called your quotient identities. These should not be new. We have our even and odd. You need to remember that sine and tangent are even. Okay, so that these are even. No, correction. I was wrong. Those are odd. And that this cosine is an even. New to us are the Pythagorean identities. So similar to what you learned back in school, at least in 8th, 9th grade, is the Pythagorean theorem. So a squared plus b squared equals c squared. We can use the unit circle and a bit of trig magic, and we can derive these three trig functions, these trig identities. These are probably the most useful thing we're going to use in this whole section, so just keep that in mind. Let's do an example. I'm going to be doing the example on page 351 of your book, and it talks about the idea of simplifying things. So simplify the sine of x times the cosine squared of x. Notice it's cosine squared, not a cosine of x squared. That's something completely different. Minus sine of x. So we want to get this down to a singular, simple answer. The question is, how do we do it? So we're going to use our identities to shrink it down. First, let's think some basic math. I have multiple terms with that include sine. So I can take out sine. And what am I left with? Cosine squared of x minus 1. All right. So cosine squared of x minus 1 is very similar to one of our trig identities. Okay? But it has to match it exactly. So what I want to do is try to somehow make this equal 1 minus cosine squared of x. So how do I do that? Well, I can factor out a negative from this internal section. So I get negative sine of x. By adding in that negative, it allows us to modify this piece as a 1 minus cosine squared of x. Now this is where we can start substituting in. Using our Pythagorean, I can say that this is now negative sine of x times sine squared of x. So my final answer is negative sine cubed of x. Now that is not pretty, and I would never want to play with it, but the idea is it's still simpler in this form than it was in the original. So you're using identities to make things theoretically simpler.